Alright, here we are. This is episode 3 of Backyard Science, and today we're going to think about sinking and floating. So, my daughters helped me collect some objects from around the house here. We've got a light bulb, a small funnel, a planter dish thing it looks like, a tennis ball, a lacrosse ball, and a pretty chewed up dog bone that belongs to our dog who's underneath the camera right now. You might see her in a minute. And so what we're going to do in sinking and floating, and this is a great activity to use a certain pedagogical technique we call predict, observe, explain. So we're going to do that before we test to see whether these things sink or float down in this bucket. Let's check out the bucket down here. And so after we make our predictions, we will put each of these objects in the bucket to see what sinks and floats, and then we'll try to explain our observations and see how they mesh with our predictions. Here's a dog bone. Tilly, come here. Come on. She's not going to come out. She's camera shy. Okay, we'll write down our predictions on the board, and Annabelle behind the camera is going to help me do that, and then we'll do our tests in just a moment. Alright, let's start with our predictions. And so I've listed the objects here. We got a lacrosse ball, tennis ball, dog bone, funnel, light bulb, and a pot base. I didn't know what else to call that. So here's a lacrosse ball. Annabelle's a lacrosse player. What do you think? Is this going to sink or float?
I probably think it's going to sink.
It's going to sink. Okay. And so we'll write sink down as our prediction. All right, Annabelle, what do you think about the tennis ball?
It's probably going to float.
You think it's going to float? All
since
right.
It's lighter.
Okay. Let's think about that reasoning when we explain it. What about Tilly's chewed up dog bone? Sink or float?
I think it might float since it's been chewed a little bit and it's relatively light.
Here, let's give it to the dog, see what she thinks. She's gonna chew on it before she tells us. How about this funnel? What do you think about the funnel?
It's gonna float since it's very light.
It's gonna float because it's light, you think? Okay.
Yeah.
And what about this light bulb? You want to check that out? What do you think about it?
I think it might float.
Think it might
since
float?
It's made of very light material.
Because it's light as well?
Yeah.
Okay. Alright, and then finally, what about the base for this planter, this pot?
I think it might sink.
Think it's going to sink?
Yeah.
Okay. Alright. So we've got our predictions now. Now the next part of our activity here is the observations. This is called POE. Predict, observe, explain. So we've made our predictions. We're actually going to run the experiment now and see what happens, and then we'll write down up there what actually happens, okay? Okay, so Annabelle's going to do the testing for us down here in the bucket of science with the objects of science, and I'm going to write down what actually happens up on our board under the observe section. So, Annabelle, what are we starting with first?
The lacrosse ball.
Okay, lacrosse ball. Put it in there, and our prediction was sink, so let's see what happens. Sink?
Yes.
Definitely sinks. Okay, let's get that one out of there. And the next object that we had was the tennis ball, and our prediction there was float. So let's check it out. Totally floats. Right? Alright. Next we had the dog bone. Were we able to get that from Tilly? Yeah. Okay, and our prediction was float. What do you think? Drop it in.
Oh, it sunk.
It sinks, but what'd you observe about the way it sunk?
It sunk slowly.
Yeah, it sunk like more slowly than the lacrosse ball, didn't it?
Yeah.
Okay.
It didn't drop down immediately.
Okay. Now, the next on the list is the funnel. And our prediction was float. Was it floating?
Yeah, I think it was the way. Yeah, it floats. It was just the way I put it under.
Oh, well, it was floating before too, right?
Yeah, it floats.
Even when it fills up with water, it floats right underneath the surface. Okay.
It's just the way you put it in. Like if you put it the top first.
But it floats either way.
Yeah.
Okay, light bulb. Totally floats.
Definitely.
It's a major floater.
It makes a noise.
That's an interesting noise. Okay, pop base. Pretty confident about that one?
Yeah,
That's a sinker.
immediately sunk.
Okay. All right, now our job is to see if we can explain why those things happen. Okay? So we're going to do that next. Okay, we've got our predictions, we've got our observations, now we're going to try to do some explanation. And it looks like in all but one case, our predictions were actually what happened. So, the lacrosse ball, we thought it would sink and it did sink. Why do we think that lacrosse ball sank, Annabelle? What's your thought?
'Cause the lacrosse ball is made of rubber and it's not hollow. It's
Okay.
rubber all the way.
Oh, it's not hollow. That's interesting. Okay. So what do you mean not hollow? Like if it's hollow, what's inside of it?
Like, 'cause lighter things.
Okay.
Like it's rubber all the way through.
Okay. It's all rubber.
Yeah.
So I'm going to put not hollow, all rubber. Okay. Let's move on to the tennis ball. You thought that would float. And it did float. Like why do you think it would float?
Because it's hollow.
Okay.
If you cut it open, it's hollow inside. There's just air.
Okay. So that's interesting. Air inside. So I wrote that down too, instead of the rubber all the way through, air inside. I think that has something to do with it. Now, what about the dog bone? That one messed us up. You thought it might float, but it actually sank.
Yeah.
So what about the dog bone?
When you picked it up, it feels very light, but it actually sunk.
Okay. So why do you think it sank?
I don't know. Maybe it sank because of like the way we put it in, or maybe it's just because the material, like it's heavier than the water.
Okay.
It's denser.
Oh, okay. Okay, that's interesting. So it feels light because it's small, but maybe it's denser. Okay. I'm going to write denser even though light, because you said it feels light, right?
Yeah.
Okay, is that fair to write that down?
Mhm.
Denser even though light. Okay. What about the funnel? Float, float.
The funnel definitely would float because it is very light, and because it's also very small.
Okay.
But the way we first put it in, it kind of sunk a little bit because I put it in top first,
Okay.
wide part first.
So it's light and small. And even though it sunk a little bit, it still didn't go all the way to the bottom, right?
Yeah.
It's just sunk below the surface. So that's the same as floating, I think. It didn't sink. Light bulb, float, float. Why do you think it floated?
It's also very light, and I think it's because of the materials.
Okay.
Like,
It's light, but what's
Because
its
it's made-
size compared to like the dog bone?
it's very it's bigger than the dog bone, much bigger, but like it's lighter.
Okay. So it's light and big. That's interesting, because like the funnel floated and it was light and small.
Yeah.
Pot base, sink, sink. Why do you think it sank?
Because it's made of ceramic, and
Okay.
ceramic is typically heavy,
Okay.
and it was kind of heavy when you picked it up.
Okay, heavy ceramic. All right, cool. Okay, so those are our explanations. Now we'll stop and think about it, and then we'll try to see if we can formalize it a little bit and understand why some things actually float and some things sink. Okay, let's start to think about why some of those predictions came true and why some of them didn't. So let's think about the key words that Annabelle used in her explanations of these things. She said things like light, heavy, sorry, I can't write well, small, big. She said dense once. I think the word was denser. Okay, so let's think about what we're working with here. It's some combination of light and heavy, small and big, relating to this idea of density. So I'm going to draw a little picture to see if we can figure it out. Imagine that this is the container, this is the bucket, right? And here's the water level in that bucket, this blue line. And let's put something in there that floated. So let's choose one thing that floated. Like the tennis ball floated really well, right? So let's draw the tennis ball floating. And it floated pretty high. It wasn't like floating underwater like the funnel. It was floating on the water, sort of like this. Let me get rid of that water line in there. So here's the tennis ball. So why did the tennis ball float? Well, I think that a student would probably say that the tennis ball is light, because it feels lightweight, it doesn't feel heavy. So they would use a word like light. And they might say that it's kind of big, or not big and not small, but in the middle. So their size characterization might be medium sized, or something like that. And remember the other words that Annabelle used that are really important here, I think, was this idea of something being hollow or not. And so the tennis ball, if we cut it open, remember I think she said there'd be air inside. It was totally not coaching at all. These are her ideas. So there's air inside, it's hollow, and that makes it lighter for its size. So here's the physics behind why something floats or sinks, or in this case, why the tennis ball was floating. Well, the tennis ball and every object near Earth's surface has a weight. The Earth is pulling it towards the middle of the Earth, and that's why we have a weight when we get on a scale. That's why something sits on the ground, because it weighs something, and there's a gravitational attraction that the Earth is pulling on it. So I'm going to draw an arrow to indicate that. Okay? And here it is. We're just going to put a W next to that arrow to indicate that that's the weight of the tennis ball. It's not a big weight. It's a smaller weight than the lacrosse ball. The lacrosse ball has a bigger weight because it's heavier. But the reason it sits here is because something else is pushing up on it. And in this case, the thing that is pushing up on it is the water. So there's a force on the ball by the water that is the same amount that's pushing up. I'm just going to put F for force. Okay, the water is pushing up the same amount. If we take something else that sunk, like the lacrosse ball sank. So the lacrosse ball is down here, right? On the bottom. It has a weight, a bigger weight, and it didn't have the water pushing up on it as much, so it sank down. The reason it stops at the bottom is because the bucket pushes up on it. So now there's a bucket force here pushing up on it. The point is that if something has a small enough weight for its size, then the water can push up on it enough to keep it afloat. And that's related to this idea of density. Now there's a lot of things going on here, and this is one of those concepts that seems pretty simple, but it's really complex. And most people have some alternative conceptions about it. But density is the combination of the light and heavy and the small and big. Density is equal to the mass of an object divided by the volume of an object. Okay? Now, if that number is big relative to the density of water, the object sinks. If that number is small relative to the density of water, the object floats. So this keyword that we'd want to build on in Annabelle's explanations was denser. When she was talking about denser, we need to fill that in, and that's where we need to go from. Now, this is a complex concept. High school physics students, university students often conflate, which means mix up density with size and mass. They're related in a specific way, but it's confusing in our heads to make sense of it. Whether something sinks or floats depends on relative density, the density of the object relative to the density of water. So the key thing here is density and then relative density. Now, you don't expect a lot of third graders to be able to put these things together. Science learning is progression that goes between, Annabelle's a sixth grader, so she was helping as a sixth grader, but since we're talking about elementary school kids, I thought I'd move it back a little bit. Don't expect many sixth graders to have all these ideas put together. Learning about this stuff is a progression that we deepen over time, deepen our conceptual understanding. In the elementary years, the predict, observe, explain idea is probably as far as we would want to go. in 6th grade science, where Annabelle is now, we want to start to think about putting together this idea of density. Somewhere around 8th grade, we probably want to think about this idea of relative density and why things sink or float and these forces. In fact, it's in high school physics where we really make sense of these forces that I've drawn in this diagram. So it doesn't all come at once, okay? Ideas like this come early. So we're going to put ideas like this in sort of grades 3 to 5. We'll put ideas like density here in grade 6. We'll put ideas like relative density somewhere around grade 8. And finally, when we put all this together to think about the forces and the nature of those forces, we're talking about grade 10 to 12. Okay? So it's a progression. Don't feel bad if a lot of this is confusing. This is a progression. The idea behind the Backyard Science episode is to introduce the Predict, Observe, Explain framework and also show you where the start of this conceptual understanding is for density. Okay, so that's our Backyard Science for today on sinking and floating.